For this example, what we're going to do is we're going to kind of synthesize everything we've done so far into one single unified way of looking at problems. So one thing you might want to do is find what the tangent line looks like when you are graphing something that's determined parametrically. This is pretty common for when you're trying to, what we're going to talk about as you learn more in calculus is the idea of tangent normal vectors. This is a big deal. So learning how to do this kind of sets the stage for that. Anyway, so what we want to do is say I've got some sort of curve. Let's plot it. Let's find some values and plot it. And then we're going to find the equation of the line tangent to the curve. Now, notice that we're doing it at t equals -1/2, so it probably makes sense to actually make one of the points we plot. So let's go ahead and start there. So we're going to say if t is -1/2, maybe we'll plot a couple to the left of that and then a couple to the right. So we'll say -2, -1, -1/2, 0. Maybe +1/2, 1, 2, 3, 4. Let's not even plot. Honestly, let's not even plot 3. Let's kind of step this up. Let's do like 3/2 and 2, and we might even do -1/2. So -3/2. So we'll come back and plot that. And you can do this out of order, right? Obviously. It's going to mess up your orientation, so just be careful. So if we do the x value here, we're going to get -16. So that's going to be way, way out there. So let's not do -16. Let's replace this with -3/2. That's still going to be way out there. So -12, but whatever. And then you're going to have -8, -4, 0, 4, 8, 12, and 16. And then for y, when we have -3/2, well, 3/2 squared is 9/4. And that's going to cancel with that 4, so 1 minus 9 is -8. So -1 here, 1 minus 4, that's -3. 1/2 squared is 1/4. So this is actually 0. And then at 0, we get 1. At 1/2, we also get 0. At 1, we get -3, then -8. And I'm not even going to consider this. So I'm not even going to consider these either because they're way out there. And you can do whatever you want. Maybe I should have plotted down to the 1/4 level. That might have been cleaner because I don't have that many points here. So I have -1. It's -8, -3, 2, 3, 4, 5, 6, 7, 8. So it's all the way out here, down here. And then -4, 0. And then 0, 1. And then there and there. And so what you're going to find is something that's like something like that, right? So then what we want to do is we want to draw that tangent line. And this is all an approximation, which is the whole point, right? I'm drawing this thing, I'm getting kind of close, but we need to figure out what the actual line looks like. So what we're going to do is we're going to use the point slope method, and we're going to use what we've learned about this to get, oh, by the way, we also have, we're going to use that point slope method to get our equation line. The orientation is in the normal, it's aligned with the x direction, so you can see it moving that way. Anyway, so let's come over here. Pretty simple stuff. We're going to do the same thing we did before. We're going to say that dy dx is dy dt divided by dx dt. And dy dt here is -8t, sorry. And the derivative of x with respect to t is 8, so that gets me negative t. Well, that's not too bad at all. And so then what we do is we have to evaluate that at this point. So we need the slope is the slope is 1/2. Okay, the slope's 1/2, but we need the intercept. We say, okay, what is the intercept of this line? Now there's a couple ways to do this. One of those is you could do the point slope method. The point slope method is probably the most reliable. That's the idea that you say y minus y0 equals m x minus x0. And then these are just points on the line. So you could pick any 2 points here. I'm sorry, you wouldn't pick any 2 points. You'd pick specifically these 2 points. In fact, actually, that's how you have to do it. There's another way to do this, but you should do it this way. So you specifically pick the points, because the only point that's guaranteed to be on the line is the one where it's actually tangent. So that's going to be the one you're going to want to pick. So then you're going to say y minus 0 equals 1/2 x minus negative 4. So y equals 1/2 x plus 2, right? Because that's going to be 1/2 x plus 4. So that's 1/2 x. 1/2 times 4 is 2. So, apologies, I was thinking something different. This you should use the point. You use the, since this is t is negative 1/2, that's what you want to use there. So 1/2 x plus 2. All right, so let's take a look. Let's see how well we did. Well, technically, 1/2 x plus 2 should have hit here. So my drawing wasn't perfectly good. I actually shot above it. But the slope was pretty okay. The slope was actually a little too high. What I drew was a little too high because it went from negative 4, 0, and rose higher than 0, 2. So my graph wasn't great. And in fact, this even bends down a little. So I know that my graph wasn't perfect. That's why we want to do these things numerically. You can't just inspect the graph. But what's neat about this is that we were able to put together some of this stuff. We were able to put together this idea of the tangent line from this sort of an introductory calculus skill, and we were able to combine it with the parametric graph. So if you can do this problem, you have a pretty good understanding of a lot of these pieces and how they fit together.